Good evening, everyone.
Good evening, sir.
Yes, we'll wait for a few minutes. Good evening, everyone. Are you able to hear properly?
Good evening, sir.
Yes. Shall we start?
Yes, sir.
As we discussed, there are two questions you people asked that I will explain because I am not yet received the worksheet. We will start polynomials meanwhile. Polynomials, our chapter 2. Forget about chapter 2. This is the introduction topic to algebra of grade 10. It's one part of the algebra. So, what do you understand by polynomial from grade 9? Anyone can open up and can explain. From grade 9, what is meant by polynomial? Anyone? What is meant by polynomial? Anyone can explain? And what are the different types of polynomial? I think this topic we already discussed in the first class. Before starting the real numbers, I explained. Different types of polynomials. Anyone can brief? Guys, I'm asking you. Anyone can brief?
Polynomials are algebraic expressions.
Algebraic expressions, yes.
So they are the expressions which contain degrees, sir.
When you can call an expression is an algebraic expression?
When they have variables,
Combination of
degrees.
coefficients. Those coefficients are called literal coefficients and combined with arithmetic operators, correct?
Yes, sir.
If equality symbol is there in between the coefficients or in between the terms, then we can call as algebraic equations. If it is not equal to anything, then it is called algebraic expressions, correct? Now, we already told like variables. Based on the number of variables, there is a classification. Anyone can give the classification based on variables? Classification of polynomials based on variables.
So monomial, binomial, trinomial.
That is number of terms. That is little different, no? Monomial, binomial, trinomial, polynomial in the sense more than one term. But if it is a single variable, two variable,
Linear polynomial.
we won't call linear. Linear is deciding by the single variable. Just there is no separate name. It's a single variable. That's it. A single variable can be a linear. A single variable can be a linear, a quadratic, or a cubic, or a biquadratic. Let us explain.
So what is biquadratic?
Sorry guys, somebody is asking something.
Sir, what is biquadratic?
I'll tell you. Ax plus b
Okay, sir.
is single variable and whose degree is 1. Ax square plus bx plus c, a single variable whose degree is 2. Ax cube plus bx square plus cx plus d. This is also single variable. This is called quadratic. And the degree is 3. This is cubic. ax power 4 plus bx cube plus cx square plus dx plus e. This is single variable, but the degree is 4. This is called biquadratic. Got it? What is the difference between, like, a polynomial means any expression having more than 2 terms, it is called polynomial. We can't say this is not a polynomial. Yes, these are also polynomials, but these are the polynomials of with different degrees of single variable polynomials. Got it? How I can explain? See, this is polynomial. When I can say this is polynomial, see, this is first term, this is second term. So it's a polynomial. Ax plus b is a polynomial of single variable with degree 1. Polynomial means any algebraic expression which is more than one term. Binomial, trinomial, everything comes under polynomials only. If it is monomial, we can't say it is poly. Poly means the meaning of poly means many, more than one. Is it clear, guys, what I'm saying? Polymers. In chemistry, what is the meaning of polymers? Polytechnic. What is the meaning of polytechnic colleges? Is it clear, guys, what I'm trying to say?
Yes, sir.
Suppose the same thing I can take in a different way also. A linear equation of two variables, ax plus by plus c. This is a linear equation whose degree is 1, but two variable. This is also a polynomial of two variable of degree 1. A linear equation of two variable, linear equation of three variable. Cz plus d is, this is ax by cz, where a, b, c, d are coefficients or constants, and x, y, z are variables. So this also a polynomial. What kind of polynomial? This is a polynomial of three variables of degree 1. Is it clear, guys? What is exact meaning of polynomial? Any expression you can call as a polynomial if it is having more than one term. Is it clear? But again, based on the degree, based on the number of variables, we are having the classification. Throughout the expression, it is having only one variable. It is a single variable expression of different degrees, like quadratic equation of single variable, biquadratic, cubic, and more than that. Guys, is it clear, or am I confusing too much?
Sir, can you repeat once more, sir? Your voice was breaking, sir. I had internet issue.
Guys, for everyone, is my voice is breaking or only for one?
No, sir. I had got disconnected just for a minute, sir.
Yeah. See, what I'm trying to say is polynomial in the sense it doesn't matter whether it is having how many variables or what is its degree. It should be more than one term. More than one term. Any kind of algebraic expression, if it is having more than one term, is called polynomial. Nomial means, poly means many terms, more than one term. Suppose if I am taking linear equations, I can say linear equations of many kinds. Ax plus b, a linear equation. See, whenever I said linear, its degree is 1 of one variable. If I am talking about ax plus by plus c, this is the linear equation of two variable. And if I am talking about ax plus by plus cz plus d, a linear equation of three variable. And one side, if I'm taking a single variable, but different polynomials also I can create. A single variable polynomials of different types. Ax plus b, a linear equation of one variable with degree 1, which already explained. Ax square plus bx plus c. Yes, single variable. You can't say it is a monomial. It's a polynomial of degree 2, a single variable of degree 3, a single variable of degree 4. But we are having specific names because we are going to discuss these equations as a separate chapters. This is called quadratic equation. This is called quadratic expressions, or this is cubic expression. This is biquadratic expressions. Is it clear what is exact meaning of polynomials?
Yes, sir.
Now we are moving to a little bit. All these things actually it is we already introduced these things in grade 9 itself. Will you agree with me?
Yes, sir.
Correct or not? Now, based on our
Yes, sir.
previous classes, now we can say linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial. So I'm clearly said it's a linear polynomial. So here I can specify the linear polynomial means where the degree is 1. Where the degree is 1. Here the degree is 2. Here the degree is 3. Here the degree is 4. Can you anyone one person can give example of linear polynomial, an example of quadratic polynomial, an example of cubic polynomial, an example of biquadratic polynomial? Anyone? Here I am not specifying how many variables, just I am talking about linear polynomial. It might be 2 variable, or it might be 3 variable, or it might be 4 variable also. But it should be a linear polynomial. When I can say the linear polynomial, a linear polynomial is a polynomial whose degree is 1.
So 2x plus 10.
Yes, super. 2x plus 10. Next.
So 5x square plus 4x plus 8.
5x square
So
plus
2x
4.
square plus 1x plus 8.
So this also comes under quadratic polynomial. 2x square plus x plus 8. Next.
So
So
5x
8x
cube plus
cube
3.
8x cube plus 3. Yes. It's a because remaining things are zeros. Next.
So 10x to the power 4 plus 8.
8. Yes, super. It's also different polynomials. Now, if I am writing an equation like this, x square plus y square plus 2xy plus x square plus y square plus 2xy plus 3x plus 4y plus 8 is 8. In which category I have to keep this one?
Quadratic, sir.
So quadratic polynomial.
Yes, it's a quadratic polynomial. Why it is a quadratic polynomial?
So because the highest
The
degree
Sir,
is
highest
2,
because the
sir.
degree.
highest degree of the variable is 2, sir.
Correct. Might be it is having 2 variables. But here I am not worrying about whether it is 2 variable or 3 variable. What is its degree, whether it is polynomial or not. But in our syllabus, maximum we will deal either either single variable of linear equation, quadratic equation, or linear expression or quadratic expression, or linear polynomial or quadratic polynomial of single variable, oddly single variable, or sometimes cubic expression also, or linear equation of one variable. We already done in grade 6 how to solve ax plus b is equal to 0. What are the solutions of ax plus b? Linear equations of two variables that we are going to do in grade 10. We done in grade 9 also. And in grade 12, we are going to do linear equation of three variables. So more than that, we won't discuss. These kind of equations for understanding purpose, we will discuss in different topics, not in algebra. What we are going to discuss?
Yes, sir.
Now, what is meant by zeros of a polynomial from your earlier classes? Zeros of a polynomial. What is meant by zeros of a polynomial? How you can explain? Guys, option 2 you only.
So for any variable x or y, if we consider a value and substitute it in the place of the variable, if we get the final answer as 0, then we can say that number is the 0 of the polynomial, sir.
Good. Any other explanation from anyone? Suppose if I am taking ax square plus bx plus c, a quadratic polynomial of p of x I am taking, or ax plus b, this is some p2 of x, second polynomial. For different values of x, suppose I can substitute x is equal to 0, 1, 2, 3, or any fraction 3 by 2, 5 by 3, or minus 1, minus 5, something I can substitute. Based on these kind of coefficients, these equations will use different values. Suppose if I am taking x square plus x plus 1, if I am taking p of 1, that means if I am substituting in place of x is equal to 1, I will get 1 plus 1 plus 1. This is 3. If I am substituting p of minus 1, I will get 1 minus 1 plus 1. It is 1. If I am substituting p of 0, I will get answer is plus 1. There will be some particular value. Suppose there is a value such that if I am substituting k, after substituting k, if I got the answer is 0, k is called zeros of this polynomial. Zeros of this polynomial. Got it? What is the meaning of zeros of the polynomial? Anyone having any doubt? I think this also we done in grade 9. Am I right?
Yes, sir.
Yeah. Now, a little bit new thing we are going to discuss. How we can identify how many zeros are available, how it is related. So, as I discussed earlier, I am going to discuss only single variable polynomial here. I am not going to discuss multivariable polynomial, because if it is multivariable polynomial, we are having a separate chapter in this grade 10 itself. We are not going to discuss multivariable higher order. Higher order means quadratic multivariable of second order, third order. We are not going to discuss. But means two variable or three variable of linear equations only is part of our syllabus. Now, suppose if I am taking 3x plus 2, it will be easy to calculate zeros of the polynomial. Substitute is equal to 0, the whole expression. If I am substituting x is equal to minus 2 by 3, my p of minus 2 by 3 will be 0. So where x is equal to minus 2 by 3 is the 0 of the given polynomial. Yes, 3x plus 2. What is its nature? Single variable, degree 1. And number of zeros are Number of zeros of polynomial are 1. What is it means? How my number of zeros of the polynomial are connected to given expression? How to find the how many number of zeros? How many number of zeros are available for a given polynomial of single variable? Clearly, I am mentioning this concept I can't apply and I can't assure you for if variable is more than 1. Given polynomial of single variable of and degree 1 degree n, where n is any positive natural number. So already I'm mentioning natural number, so I'm removing positive natural number. This is how I can explain the relation between degree of a polynomial of single variable and number of zeros of that particular polynomial. How many people know this relation, which already done? Guys, anyone? Guys, again I'm asking, am I confusing this topic too much? Because what are the things we are discussing, most of the things are not available in the book. They will give briefly. Just they will discuss briefly and they will wind it up. Straight away they will go to the questions. I need your response because later you should not confuse, because once we open the book, certain things what we are discussing, it is not available. That's the reason our class is to discuss certain things which we have to understand for any kind of level. Guys, Vaishnavi,
Understood, sir.
yeah.
Understood, sir.
What is the answer for this statement?
So if the degree is 1, then the zeros of the polynomial is also 1. So there will be only 1 0.
Degree is 2.
Sir, then
zeros,
there will
sir.
be 2 zeros, sir.
So number of zeros of a polynomial is equal to degree of polynomial. A polynomial of one variable. I'm saying
Number of zeros of polynomial is equal to the degree of the polynomial.
sorry. It's why your voice is completely breaking. Can you repeat again? Hello. Anybody hear what she said? Can anyone repeat what she said?
Sir, I guess she asked how can we say that a number of zeros of a polynomial is the degree of the polynomial.
Question.
I guess, sir, I'm not sure.
I'm coming to that point. One is trial and error method. Another one is factorization method. These two methods are not satisfied by anyone and not clear also, because what are the thing we discussed? If I am saying one statement, suppose if I am proposing one statement, if I am proposing one standard statement in mathematics, it should be valid for entire group of like suppose if I am talking about natural numbers, what are the statement if I am defining for natural numbers, it should be valid for all the natural numbers. I should not substitute only 10 natural numbers. I can say this statement is valid for all 10 natural numbers. Got it what I'm saying? So this factorization method and trial and error method is not at all satisfied for up to some level. That's the reason they used the concept of geometry to explain. There are different kind of geometries we are having. Plane geometry, all the geometries we are going to touch. Practical geometry, analytical geometry. In analytical geometry, we are having some categories. One is real axis. We learned in 4th, 5th standards. I will tell you what is the meaning of real axis. Two-dimensional geometry, that is called coordinate geometry. And three-dimensional geometry, and it is called solid geometry. And in till grade 10, we will learn up to 2D. In grade 11, we are going to discuss about 3D also. Plane geometry means we already done triangles, angles, and circles. All these things comes under plane geometry, different theorems. Practical geometry means you people knows very clearly how to draw the things, how to draw a triangle, how to draw two parallel lines for a given point passing to a point, how to draw a perpendicular line, how to bisect a line. These things will come under practical geometry. So geometry is not only valid to discuss these things. There are many things in algebra, in physics. To prove certain things, we are using geometry. It might be plane or it might be analytical, because practical geometry we will discuss only in engineering level. Just what are the thing we are doing in grade 9, 10 or 8, it's only like ABCDs for the practical geometry. Actual real practical geometry will come in engineering if we opt either civil or electrical and electronics. Major I'm talking, any designing courses related to technical or mechanical. These places you will get what is exact practical geometry, why we have to learn practical geometry. What other thing we are doing in physics, everything we can able to explain through practical geometry also. Now coming back to the point. So what is the trial and error method? Suppose if I am taking 3x plus 2, this is my p of x. Substitute x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to minus 2 by 3, x is equal to plus 2 by 3. Like this, if I am taking different variables, that means different values of x at particular positions. Like if I am taking p of 0, my answer is how much? 2. If I am taking p of 1, my answer is 5. If I am taking p of 2, my answer is 8. If I am taking p of minus 2 by 3, my answer is 0. If I am taking p of 2 by 3, my answer is how much? What is the answer? 4. Like this. So they are getting what are the values they are substituting? They are getting one and only value as 0. At x is equal to minus 2 by 3 only, they are getting p of x is 0 and its degree is 1. They concluded something, it's 0 of this polynomial is only 1. How I can conclude? If 3 is 2, I am taking ax plus b. At particular value of x, I need to get 0. So what I am doing is I am taking this is as 0 and my x is equal to minus b by a. I got only one x value. I am not getting many x values. Like that, they concluded somewhere it is related to the number of zeros of a polynomial of single variable is related to its degree. So if the degree is 2, the number of zeros are 2. If the degree is 3, the number of zeros also 3. Now coming to the second one. How they concluded this one using your quadratic expression. Ax square plus bx plus c. If I am able to write this ax square plus bx plus c in the form of x minus alpha into x minus beta, then only it can say as quadratic. Because if I am writing one more x minus of some constant, it is comes under cubic. If it is not available, if these two terms are not available, it will comes under only linear. So this can be equal to x minus alpha into x minus beta. If I am expanding x square minus alpha plus beta into x plus alpha into beta. This expression I can write as x square plus some constant into x plus some other constant into some other constant. So this both looks in same form. So here, if I am equating this expression is equal to 0, If I'm equating this expression is equal to 0, this is one expression, this is another expression. In mathematics, in maths, when product of, when some product is 0, when you can say the product is 0, when the product of some expression is 0, when it is possible, product of two numbers, product of three numbers, or product of five numbers here, or the 0. Guys, when it is possible?
Sir, if it is subtracted,
the-
sir.
When a product of an expression can be 0. A product of an expression can be 0 when it is possible.
When it is multiplied with 0.
Multiplied by 0, sir.
Yes, suppose if I am talking the product of A and B is 0, where A and B are two real numbers. Product of A and B is 0. There are possibilities, either A can be 0 or B should be 0. Correct? Or A and B should be 0. Then the whole expression can be 0. From here, I can say either x minus alpha can be 0 or x minus beta can be 0. Then only the expression can be 0. So x is equal to alpha or x is equal to beta. Even this also is not much satisfied, because there is a situations where I can't explain, I can't factorize. Suppose if I'm having x square minus 3x plus 2. This can be factorized like this: x square minus 2, x minus 2 into x minus 1. If I'm multiplying this one, x square minus 2x minus x plus 2. This will be x square minus 3x plus 2. So this expression can be written in the form of product of two linear equations of degree 1. So if I'm taking this is equal to 0 to calculate the zeros of the polynomial, either x minus 2 is equal to 0 or x minus 1 is equal to 0, because this product is 0 means either any one must be 0, then only the product is 0. Suppose if I am talking about A into B is 0, where A is some number, B is some number, how it can be 0? Might be the addition or subtraction can be 0, even both the values are exist, but the product is 0. When you can say the product is 0? Any one should be 0, then only it can be 0 now. Right, guys, got it what I'm trying to say?
Yes, sir.
So
Sir.
here they got x is equal to 2 or x is equal to 1. So he is taking a quadratic expression after solving using the factorization method is equal to 1. But here I am taking particular values. I am not taking different values. I am not taking any unknown values. Sir, how we can say by taking only particular values and you can say it is related to degree? Yes, that's the reason they used geometry to explain anything. What they done in geometry is they took the curve. That means they draw the. Suppose if I am taking p of x is equal to ax square plus bx plus c, or p of x is equal to ax plus b, or p of x is equal to ax cube plus bx plus c, bx square plus cx plus d. They observe certain things. If I am taking straight line, this is giving a straight line, and this is giving a curve. They name it as quadratic curve. This is giving a curve. Again, this is a curve. They name it as cubic curve. They observed what they observed is.
Sir,
Yes.
Sir, Durlab Tani said that he has power cut, sir.
Okay. Yeah. See, whatever the x values I am taking, suppose x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5, you will get different values of p of x. So they plotted graph of each and everything. So if I am taking a linear equation of single variable, they got a straight line. And this straight line is intersecting x-axis only at one point. Now, if I am doing the same job for the quadratic expression, they found that the curve is intersecting x-axis at 2 points, or the curve is not even intersecting x-axis at any one point, or the curve is not even intersecting both the axes. These three possibilities they observe. Out of these three possibilities, anything can you say? Any other possibilities can you say?
For touching the x-axis.
Touching x-axis. Super. And cubic curve, they observe it is touching the x-axis at 3 points. It is touching the x-axis at 3 points, and sometimes it is touching the x-axis at only 1 point. This is also a cubic curve. Y is equal to x cubic curve will look like this. So what they observed is, graphically they concluded something. If I am taking the graph between the solutions and what are the values I am substituting, and how many times the curve is intersecting the x-axis, that will give the number of zeros of the polynomial. In case of linear polynomial, it's a straight line and it is touching only at 1 point, or it won't touch. It won't touch. I will show you both the things. Touching only at 1 point means it will be like this, or it will be like this, or it will be like this. Can you draw any straight line which will intersect the x-axis at 2 points? Is it possible? Geometrically, is it possible? Is there any straight line will intersect the another straight line 2 times?
No, sir.
No. So they concluded this where it is touching, the point is some x comma 0. This represents y. This represents x-axis. So for this particular x value, you are getting y is 0. Your y is p of x. Your x is what are the x values you are substituting. So where it is intersecting, suppose if I am drawing the line ax plus b, it will intersect at minus b by a. That means this is a point where the line will intersect. This line I can show as ax plus b, equation of this line. So they concluded this line will touch only at 1 point because it's showing a straight line, and where it is touching, that is shows the zeros of the polynomial. Suppose, sir, what is the meaning if the straight line is not even touching anywhere on x-axis? Is these are the lines, it never touching anywhere on x-axis, correct? Guys, got it what I'm saying?
Yes, sir.
The meaning of this is it doesn't have no zeros, no real solutions. In case of other situations, no zeros means, what is this meaning? Can you give any expression which will represent this scenario? What are the values substitute? You never get that answer. Whatever the value
Zero
substitute,
polynomial.
it's a zero polynomial, simple.
Sir, I had got disconnect, sir. Just now I joined, sir.
It's a zero polynomial. Nothing, we are discussing how we can give the relation between number of zeros to the degree of a polynomial.
Okay, sir.
Different methods we approached, but we are not satisfied with the different approaches because different approaches is giving only particular examples or particular cases of the expressions. It's not covering all the situations, but graphical method which is explaining everything, and each and every scenario you can explain very easily through the graphical method. That's the reason we are
Okay, sir.
now, if I am considering, actually if it is in a physical class, I will ask you to draw using the graph papers, then you will get more clarity. Now if I am taking an expression, p of x is equal to x square minus 3x minus 4. I need at least 6 to 8 values. I will give the x values. Please calculate. -2, -1, 0, 1, 2, 3, 4, 5. Guys, can you calculate the p of x values by substituting these values? Substitute and let me know, anyone. Substitute and let me know.
Sir, first one is 6.
First one is 6.
Sir, can you show the expression once?
Yes.
Thank you, sir. So for -1, it is -6. And for 0, -4. And for 1, -6.
-1 it is
-6, sir.
-6. -1 is -6.
No, sir.
0, sir.
0, sir.
0. For 0 it is -4 plus, for +1 it is -6. For 2 also it is -6. Correct? For 3 also 3 it is -4. For 4 it is 0 and 5 it is 6. So if I am taking a graph, if I am plotting this graph, so at x is equal to 0, I got -4. That means at x is equal to 0, -4. That means here this is 0, -4 I am taking, for example. And at -1 it is 0. This is -1, 0 situation. And 1, at 4 it is 0 again. This is 4, 0. And again -2, 6. If it is -2, somewhere here. So the graph is coming like this. This graph is known as parabolic curve. All quadratic expressions known as parabolic curve. Keep it in mind, you will get. So it is intersecting at 2 points. See, by tracing the graph, we can able to calculate how many solutions it is having. Even though if it is a quadratic expression, it is never intersecting anywhere, then we can say it doesn't have any real roots. You will get concept of complex roots or unreal roots in future. Right now, we are not going to discuss. It doesn't have any real roots. How we can explain other than graph also, we will discuss in this chapter. Is it clear, guys, what I'm saying?
Sir, can you
Yes, sir.
explain once more, sir?
See, based on the graph, we can say how many zeros are available, how many times it is intersecting x-axis. That will give the number of zeros of this polynomial.
Okay, sir. I got it.
Okay. So I will go through your textbook some graphs. Can you explain what are the number of zeros of the polynomials?
Yes, sir.
These are the different curves. How you can explain? Case 1. The first diagram shows.
Sir, 2 zeros.
2 zeros.
Yeah. Second.
Sir, that
2
is also 2
zeros.
zeros, sir.
Then what about third case?
1,
So
sir.
1.
Sir, 1 0, sir.
Only 0, but it is violating our definition. What it means? Yeah, we discussed quadratic expressions should have 2 zeros of polynomials. What it means? It is having only one, that means its factors are same factors. It's a perfect, like if I am taking x minus 2 whole square, x square minus 4x plus 4. Its 0 is 2 comma 2, because we will get x minus 2 into x minus 2 is equal to 0, x is equal to 2 comma 2. That means it is having same zeros. Got it what I am saying?
Yes,
Yes,
sir.
Yes, sir, got it.
Then we will say there are certain cases if it is touching only, even though if it is curved, if it is touching only at one point, then we have to look into this. Even that whatever the here also I can say there are 2 zeros, but both the values are same. If I am saying alpha comma beta of the zeros, but that should be equal to single value if it is touching only at one point. Got it what I am saying?
Yes,
What
sir.
are it clearly says it is never touching any x-axis, so I can say it is no zeros. No zeros in the sense no real zeros. No real zeros. It is an imaginary, unreal solutions. Unreal solutions means complex solutions that we won't discuss. As of now, we'll say this expression has no zeros in this case because it is not touching anywhere on the x-axis. Clear what I'm saying?
Yes, sir.
Yes, sir.
See this question. How many times it is touching the x-axis?
3, sir.
Sir, 3 times.
1, 2, 3. It's a cubic equation. It is intersecting at 3 times. Even though if it is a cubic equation, it is touching only at one time. What is it meaning?
2 of the zeros are the same.
Yes. Suppose if I am taking x cube is equal to minus 1. So minus 1, minus 1, minus 1 are the zeros. Or we can say like this, only one real zero, remaining are unreals. That also you can say. Got it what I'm saying?
Sir, can you repeat again, sir?
Only one real number is zeros of the polynomial. Suppose if I am considering x cube is equal to x1 is equal to 0. This can be written as x minus 1 into x square plus x plus 1. Correct?
Yes, sir.
So this can be 0 or this can be 0. This, if I'm taking the graph for this graph is not even touching anywhere on x-axis, but this can be touching the x-axis at x is equal to 1. That means this expression is having only 1 0 of the polynomial.
Okay, sir.
What about, sir, its index is 3 now. What about remaining 2 zeros? Remaining 2 zeros are non-real numbers. Got it?
Understood, sir.
Yes, sir.
Yes, sir, got it.
What is the meaning of non-real numbers? When I am solving analytically, I will explain. Okay. When I am solving the quadratic expression, we are having the next chapter is quadratic equations. There we will discuss what is meant by non-real roots, non-real zeros. What is meant by when this situation will face. There it will be very clear answers you will get. Okay. As of now, if it is touching graphically at one point, means it is having only 1 0 real solution. That's it. Got it? What I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
You have to understand.
Yes, sir.
We can't conclude by seeing the expression. That's the reason trial and error method, factorization methods are not valid. See, if I'm by seeing the expression, I can say it is a cubic expression. So why I can't take the real the number of zeros are 3? No, always we can't say even though the index is 3, the like the order of the expression is 3, we can't say 3 zeros are available. That's the reason I can modify the statement like this. If the index of polynomial is n, the maximum number of zeros of the polynomial is n. It might be 1, or it might be 2, or it might be 3, or it might be 4, or it might be 0, or it might be n. I can say like this. So the maximum number of zeros of a polynomial is equal to degree of the polynomial. Guys, I can modify the statement. Now it is clear. Suppose if the index
sir.
in degree is 2, the possibility is either 0 or either 1 or either 2, but more than 2 not possible. It is depends upon what kind of literal coefficients it's having. Suppose if I am taking one expression x square plus x plus 1, it doesn't have any real zeros. Real zeros means whatever the x value substitute, you never get this answer is 0. You take any x value, you can take any x value, you never get x is, this expression is 0. That means this polynomial doesn't have any real zeros. Real zeros means there is no x value exists, there is no x value exists in such a way p of x can be 0. That means there is no real number for x. There is no real number for x available such that where the p of x can be 0. What it meant, what I am trying to say now. Now my our concept can be clear. How the degree of a polynomial is connected to number of zeros of the polynomial.
Yes, sir.
Yes.
Yes,
Now I
sir.
do the basic first exercise of the topic. The first exercise is clearly see here. What is saying? The first graph. How many zeros of the polynomial in the first graph?
1, sir.
1, sir.
Second.
Sir, 1, sir. Sir,
Second.
second is 2, sir.
2,
Third one.
3,
The
3.
third one is 3.
Fourth one.
1,
1.
1.
Fifth one.
1,
1.
Sixth one.
4.
Yes.
4, sir.
See the
4,
answer.
sir.
Fourth one, they mentioned it is 1. Fifth one, it is 1. Sixth one, it is 4. Y means, what you can say y means? What is the conclusion answer you have to give for if it is y means?
Sir, because it intersects
As the
x
graph
axis 1.
intersects at one point only. As the graph intersects
Yes,
at
sir.
2 points only. As the graph intersects at 3 points. Now coming to the exercise 2.1 and let me know. What is the answer for the first graph?
No 0, sir.
So no zeros. So zeros, 0, no zeros. Next.
1,
1, sir.
Sir, 1.
3, sir.
3, sir.
1, 2, 3. Next.
2,
2,
sir.
sir.
Here.
4,
4, sir.
2, 3, 4. Next.
3, sir.
Sir, 3.
Irrespective of its degree, how many times it is intersecting x-axis, that is the number of zeros.
Number of zeros of polynomial.
In higher studies, you will learn why it is deviating. Suppose if even though if x is equal to, suppose if I am taking a graph, If I'm drawing a graph between x cube minus 1 is equal to 0, if I'm taking a graph p of x is equal to x cube, or if I'm taking a graph of p of x cube is equal to x, sorry, my p of x is equal to x cube, I will get a graph like this. My graph is like this. This is 1 comma 1, this is 1 comma 1, because when I am substituting 1, even substituting minus 1, I will get the answer is minus 1. If I am substituting plus 1, answer is plus 1. Even though if it is cubic polynomial, it is intersecting x-axis only at one point, that is 0 comma 0. The number of zeros are only 1 for our level, but the same concept if you choose in CBSE, we don't have the topic, students, but if we are going for in future any JEE entrances and all, there we will discuss all 3 zeros. Out of 3 zeros, 1 zero is real number and remaining 2 zeros are second zero and third zero are non-real numbers. That's the reason what we will say is number of zeros of a polynomial is equal to degree of the polynomial. But why we can't discuss that statement as the right statement our level? Because we don't know about the non-real numbers. The name of the non-real numbers is called complex numbers. If you are free, if you are interested, you can search through the Google. There is a concept called complex numbers. This is the topic we are going to discuss in grade 11. After that, again, we are discussing the polynomial. Then they will discuss the number of zeros of a polynomial is equal to degree of the polynomial. But as of now, we are going to discuss the number of zeros of the polynomial is equal to how many times it is intersecting the x-axis. Why this doubt they got? There are some equations intersecting 3 times, but there are some equations which is intersecting either 1 time or 2 time, or sometimes it is not even intersecting. Why this difference is coming? Later only they found that whenever it is not intersecting more than 1 time, this is x, p of x is equal to x cube, but it is intersecting only at 1 time. That is means in real I can't show remaining 2 roots, 2 zeros. Remaining 2 zeros I can't show because it is not real. Only real numbers I can show here, because your x-axis contains minus infinity to plus infinity where all real numbers are there. How I can explain the non-real numbers here? So non-real numbers are not available on this graph. This graph is restricted only for real numbers. That's the reason the graph is not even touching more than 1 time here. Guys, is it clear what I'm trying to say?
Yes, sir.
So those things is beyond our curriculum. If anybody wants, we will discuss later based on your interest. But as of now, how many times it is intersecting the x-axis, that is the number of zeros of the polynomial as per our grade 10 level. You can't search Google and you can say, sir, whatever the thing we are discussing might be wrong. Yes, I can say our discussion is only limited to certain conditions. I'm not saying our discussion is wrong, but our discussion is limited to your curriculum. Got it? Shall I wind up the session with this? Next, tomorrow class, suppose if I am saying, as per my discussion, if I am taking a quadratic polynomial, the maximum number of zeros are or 2. Let's assume this alpha, beta are the zeros of the polynomial. How my coefficients of the polynomial related to zeros of the polynomial we will discuss in tomorrow class. Anyone having any doubts so far?
No doubt, sir.
No, sir.
No, sir.
Please let me know. Go through the book, because if you think a little bit deeper, you might get a lot of doubts over this topic. Just explore yourself using the Google or any Wikipedia or anything if you are interested, because it's a very huge. It's actually like an ocean. This topic is like an ocean. It is a origin of algebra, I can say. Just go through the things. Whenever, whatever the doubts you are having, please come and discuss with me. It's not at all a problem. Just come with a basic preparation for tomorrow class. Then it will be easy for us. How to divide an equation with another equation. Those things you have to do tomorrow. Yes, shall I meet in tomorrow class?
Yes, sir.
Yes, sir.
Bye
Yes,
everyone.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.